Dear friends, in class 11 we have third lesson trigonometric function and we are studying degree measure. Now let us try to understand degree measure. If there is a complete rotation, then we say it is 360 degrees. Please note, if this is initial arm and if it is rotated in a complete circle, one revolution, then it will occupy the same place. So initial arm and terminal arm will be one above the other, and terminal arm. Then we say that the rotation, the degrees are 360 degrees. What does this mean? If it is rotated half of the circle, if this is initial arm and this is half circle, if this is rotated in anti-clockwise direction, then we say half of the degrees, that is 180 degrees. If it is rotated 1/4, if this is initial arm and if it is rotated in anti-clockwise direction 1/4 of the circle, then we say the degree is 90 degree. From this only we try to define the degrees. So if initial arm is revolved 1/360th part, 1/360th part of a revolution, then the measure is called, the measure is said to be 1 degrees. Please try to understand this. What does this mean? If you are rotating 1/4 part, it becomes 90 part. If you rotate this circle if it is divided into 360 parts, if it is divided into 360 parts, then one part is called 1 degrees. This is the definition of degree. If initial arm is revolved 1/360th part, if this is initial arm and it is rotated only 1/360 part, not the complete, then this angle is said to be 1 degrees. This degree, 1 degree is divided into total 60 parts. If it is divided into 60 parts, then 1 degree, if it is divided into 60 parts, it is called as minutes. Please note, here it is written 60 and raised to, you can see one apostrophe like comma is there. So 1 degree is equal to 60 minutes, and these 60 minutes can be divided further 1 minute can be divided into 60 seconds. Please note, here for seconds we give double comma and for minutes we give one comma. So this is 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Please note, spellings are same, but these are related to degrees, minutes and seconds. Further, if the initial arm is rotated in clockwise direction, then if it is rotated in full circle, it will be negative 360 degrees. If it is rotated half of the circle, then this rotation will be negative 180 degrees. If it is rotated only 3/4 of the circle, this will be negative 90 degrees. Try to understand this. If it is rotated 1/360th part of the circle, then this will be negative 1 degrees. So this is initial arm. Initial arm is rotated in this direction. Initial arm is rotated. This is terminal arm. This is initial arm and terminal arm. So if it is rotated in clockwise direction, angles are negative, and if it is rotated in anti-clockwise direction, angles are positive. Next, angles are also measured in radians. Now see, if this is a circle of radius r, and if the length of the arc, please try to understand, this is a circle of radius r and this is the length of arc. If this length of the arc is r, then angle subtended at the center. Please note, angle subtended at the center is said to be 1 radian, and it is written as 1 raised to c, that is, this is called as 1 radian. Please note, try to understand. Now, if the length of the arc is r of a circle of radius r, of a circle of a radius r, then angle subtended at the center is 1 radian. Or this can be defined further. If a circle is of 1 unit, and the length of the arc is also 1 unit, then angle subtended at the center is 1 radian. You can define in this way or you can define in this way. So angle subtended at the center of a 1 unit circle by the arc of length 1 unit is said to be 1 radian. Thus, angle subtended at the center by an arc of length 1 unit. This arc is of length 1 unit. So, angle subtended at the center of the circle by this arc in a circle of radius 1 unit. This is a circle of radius 1 unit, and length of the arc is also 1 unit. Then, angle subtended at the center is said to be 1 radian. Please note, we have already studied circumference of the circle is 2 pi r. So, this will be total circumference of this circle will be 2 pi r. 2 pi r, radius is already 1, so this is equal to twice pi. Please try to understand. Now it means total measure of the circle is 2 pi radians. So total measure of the circle is 2 pi radians. In this case also you can try to understand. Here total circumference of the circle is 2 pi r and radius is r. So radian is equal to length upon radius. So you will get twice pi r upon r, that is equal to twice pi. It means total measure of a circle is 2 pi radians. 2 pi radians. So if the initial arm is rotated in anti-clockwise direction, then the total measure is 2 pi radian, and if it is rotated in clockwise direction, then the total measure of the circle is negative 2 pi radians. Negative 2 pi radians. So you can understand, if this is initial arm and it is rotated in this direction to get the again same position, then this becomes negative twice pi radians. So if it is rotated half circle in anti-clockwise direction, this becomes negative pi radians. And if the initial arm is rotated in anti-clockwise direction of half circle, then it becomes pi radians. So 1/4 of the circle will be in 1/4 circle in anti-clockwise direction is equal to pi by 2 radians. And if the initial arm, I will write this set, if the initial arm is rotated in clockwise direction of 1/4 of the circle, then we get negative pi by 2 radians. Thus, if theta is the angle, if this is a circle of radius r and theta is the angle subtended at the center and L is the length of the arc, then we have theta is equal to length of the arc upon radius. So angle at the center is theta radians. Theta radians is equal to length of the arc upon radius of the circle. Now let's try to understand relation between radian and real numbers. Now see, if this is a circle, if there is a circle of unit radius, this is a circle of 1 unit, that is radius is 1 unit, and let O be the center of the circle, A is any point. If there is a tangent to the circle, imagine this is a line PQ tangent to the circle at point A. So we have got PQ is a tangent to the circle of 1 unit with center O at point A. Now see, we have already studied on the number line we can represent all the real numbers. Means we can represent this is half or 0.5, root 2 is somewhere here. Means rational and irrational numbers can be represented on a number line. Similarly, you can represent negative numbers also. This is 0.5 and you will get, if this is negative 2, you will get negative root 2 as well. 1.414 is something, we know how to plot the root 2 also. So, if this is a line with real numbers on it, then if please try to understand this, if AP is rotated along the circle, we will get this rotated along the circle, something like this. This line doesn't end, so your rotation will also not end. They will go on extending in this direction. Please note, AP will rotate or will take the position on the circle in anti-clockwise direction, and if AQ is rotated, it will occupy the circle in clockwise direction. We know that on the number line all numbers can be plotted. This will be positive 1, this will be positive 2, this will be negative 1, this will be negative 2. So if this AQ is rotated along the circle, then we will get here somewhere, if this is 1 unit and this is 1 unit in negative direction, try to understand, then if when this point will touch to the circle, we will get this also negative 1, this also 1. It means this angle will be negative 1 radians. When 2 will touch the circle somewhere here, we will get negative 2 radians. Similarly, if 1 touches the circle somewhere here, we will get 1 radian. If 2 touches somewhere here, you will get 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, 7 radians, and it can, as the line doesn't end, these radians will also be making a circle and occupying the same positions on the circle. So if it is rotated in anti-clockwise direction, it will take positive values, and if it is rotated in anti-clockwise direction, it will take negative values. Please note, from this we understand that all the real numbers can be represented on the circle, or they will have some radian measure on the circle. Thus, radian and real numbers can be considered nearly same.